We are out here in the workshop again with the fire extinguisher because we're going to try a new experiment, melting some pewter and casting it into some 3D printed moulds. Two predictions for this project. One, I predict it's not going to work, and two, I predict it's not going to fail in any of the ways that I've anticipated. To start off with, our moulds. So I've got some sand here, and I have some 3D printed moulds. I've done a couple. I've printed them in this signal white PETG, and I'm going to bed them into the sand. I've got two that are just at room temperature, and I've got two that have been in the freezer all night. Although I suspect that will not make any difference at all, because these things are mostly air, and I suspect they've already come up to room temperature. So the temperature in here is, okay, I've got 18.1 degrees on this bit of wood. My mould here, 15.8, it's the one from the freezer. This one here, 15.5, 18 and 18. So these ones are already only a couple of degrees cooler, so that's nothing to worry about. Let's melt some pewter. Let's get started on this. My super sketchy melting thing is on. The melting point of PETG, based on the print temperature, I print with a nozzle temperature of 215 degrees, and the melting point of pewter is about 205 degrees. So in theory, I've got a 10-degree window there where we can get the pewter liquid and flow it into these moulds without the moulds melting, in theory. There's so many questions here. I'm just going to try it and see what happens.
Pore number 1 flows into two adjacent chambers, and rather than settling into the edges like a true liquid, the metal actually pulls back from the fine detail and the corners, leaving the moulds only partially full. The pewter does stay in the moulds though, it's not melted its way through the bottom, so that's something. Pore number 2 is similar. It also flows into two adjacent chambers, although I notice now that the mould is not level, so it flows more into the right hand end of the shot, filling less into the left hand end. Again, it's not flowing into the edges and the corners of the chambers. Pore number 3 is into the second mould design. Again, I miss and fill two adjacent chambers and then spill onto the sand. Interesting, the surface tension seems to wick the pewter out of the mould and into the lower area on the sand, until at the end there's actually not much pewter left in the mould. Most of it has been pulled out. Pore 4 is into the last empty mould, and again I generally miss on this and spill it on the sand, and again it wicks most of the pewter out of the mould into the lower area. So one conclusion we can already draw from this is that molten pewter does not behave like a liquid in the traditional sense, and that attempting to mould it like a liquid is not going to have the desired results. Pore number 5 is into the only remaining slot on this small mould design, and this goes wrong in a new way, in that not only do I spill it onto the sand, but it actually eats through the side of my sand container and flows onto my sacrificial mat, bubbling away there. At this point I've reached for the fire extinguisher, but thankfully only scorches the wood. This does demonstrate that the PETG I've printed these moulds in is definitely more suited than other types of plastic in avoiding being melted by the heat of the pewter. The final pour, number 6, is into this large mould design again, and here we see the pewter does behave more like a liquid. Because the moulds are not level, it actually runs into the lower area, although it doesn't fill the lower area. Have a look here just how much the pewter is overhanging the edge of that mould before being pulled back in by the surface tension.
Well, that was very exciting, and it did find a number of ways to fail that I was not expecting. The flow of the metal is the biggest issue, not at all what I would have considered. I think I need to design moulds that guide it, because it tended to overflow and then the surface tension would actually pull the liquid back out of the mould. It's fascinating. I will let these cool and then try and demould them, and that's the next difficulty to overcome, working out whether the molten plastic is actually separable from the cast pewter now. Thinking designing breakaway moulds would be a win next time. I don't think a two-part mould would help. Those seem fairly determinedly these seem to be fused fairly thoroughly. Maybe some mould release. Force applied there would rather split the mould than separate the piece from the mould. So none of these things have really taken on the shape of the mould, that's true. Time for a coffee, I think.